This video will be about adding the rubber band powertrain to your car. What you'll need is you'll need a rubber band, some string, a pair of scissors. We're going to make a loop which will grab around not this axle where the rubber bands are attached because you don't want to move it, but it's going to grab one of the supports at the base of the tower opposite the power axle near the steering axle. So this is the axle that we use for steering. I'll attach my rubber band up here, but I'll use a loop of string. The reason why, if I wrap this rubber band, let's say around my finger, you can see that this part of the rubber band over here stretches a lot, while this part remains kind of loose because my finger is grabbing onto the rubber. The same thing happens when you tie this around the tube, and that's going to make it very difficult to get a consistent elastic coefficient or spring constant for, elastic coefficient is something else, but a spring constant for your rubber band. Now the rubber band already, it doesn't have a really perfect spring constant because when I pull it, it gets more organized and it releases heat. And after it releases heat, it's then not as forceful as it was when it was hotter. If you heat up a rubber band, that will actually also, the temperature can increase or decrease the amount of tension. So there's a lot of variables from the rubber band that can change the amount of energy. But one of them that we can control is by making sure we stretch all of the rubber together. And using string, if I have string holding the rubber band, you can see how it doesn't, there's not a lot of rubber wrapped around the string. So that means if I use string at both ends of the rubber band, when I pull it, I'm stretching all of the rubber at the same time. And so that makes measuring the amount of stretch. So if I want to measure the amount of stretch, the way I can do that is, right now the rubber band isn't really, there's a point where it's not really applying force, so it's not really being stretched. So what I can do is make that point where it's not really stretched 0, and then I can measure, this would be how much I'm stretching it. And while we're doing this, I'll show you how to measure the spring constant that isn't quite so constant for a rubber band. And again, I hope you are using the transcripts because that makes it easier to get more out of these long videos. So what I'm doing is I'm figuring out like how far can I stretch this rubber band before it's really pulling. And since we have this, you can see how like there's a point where we can actually see the spring scale move. And that's when we're actually really pulling the rubber band. So at this point, this would be what's called an equilibrium point of the spring, and I can treat this stretch here as 0. Even though this is about close to 90 millimeters long, the rubber band isn't being stretched until I drag it to the point where this spring scale starts to move. So the way I can measure the spring constant of the rubber band is I just pull it some distance. I'll go until, let's see, till I'm right at 3 newtons, and it looks like at 3 newtons I'm stretched to 261 millimeters. So I'll write that down. 261 millimeters. So this is my, what would be my x value is 261 millimeters. And my force at that x, I'll say my force at 261 millimeters was 3 newtons. So my K, that spring constant, is going to be the force divided by that distance stretched. So in that case, that would be 3 newtons divided by 261 millimeters. Or 3 newtons over 0.261 meters. And that's how you can calculate the spring constant, and then you just do 3 divided by 0.261, and that would give you the spring constant in newtons per meter. So in this case, this is about, it looks like roughly around 10 or more newtons per meter. That would be our spring constant. I'll let you do the mathematical exercise there. And I'll return to the main thing I wanted to show in this video, which is how to attach the rubber band in a way where we can use the spring constant that we get, which will be different for every single rubber band. So this value here is not going to be for your own rubber band. Your own rubber band will have a different value. So in order to attach this rubber band to my drive string, I will use one loop here, and then I'm going to use a string with 2 more loops. I want the string that's attached to the rear axle and one end of the rubber band to be long enough so that I can get all of the power out of the rubber band, but short enough so that when the rubber band relaxes, this wheel is able to rotate freely without any further resistance, and the car can go as far as the energy put into it will allow. So first I'll just make that front loop, which has to be long enough to wrap around here, and the rubber band doesn't have to be very large. If you make it too large, that will reduce how much power you can put into your rubber band. If you make it too small, you'll have to try again. As a rough guide, this loop should be about 4 times the distance of the tube, because in order to wrap around the tube, it has to be pi times the diameter of the tube. So this is long enough, like 1, 2, 3, 4. It can be a little bit shorter than 4, but it helps to have a margin of error. It's generally good practice when designing things to make them, to allow for some margin of error when it's actually made. So that in this case the string can be a little bit shorter, the loop could be a little bit shorter, and it will still work. So you can see how this string can now loop around the axle. So that's one loop, and I'm going to do the same thing kind of with the rubber band in that loop. I'm going to pass one end of the rubber band into itself. And as long as these two loops are held apart and neither of them break, then this bond here will not come apart. And you can see how it can get pretty much the full stretch out of the rubber band. There's a little bit of rubber in here that we can't stretch. There's actually a way of making this a little bit better. If I would have thought of it in advance, this would be a shorter video. But instead of making the loop separately, it's better if we make the loop around the rubber band itself. So if I make the loop this way, you can see how the amount of rubber that's not stretched is actually much smaller. So I can get a much better value here. And again, I want to make sure that my loop is larger, is at least 4 times longer than the diameter of the tube that I'm wrapping it around. So let's see. 1, 2, 3. Okay, so it's about 4 times wider, which is good. I'll clip off the extra there. And now you can see that we're getting even more of the stretch from the full rubber band. And I want to make sure, I accidentally almost wrapped it around the steering wheels, which could change the alignment of my car, and that would be bad. I want to make sure that I wrap it around a part of the car that's not used for steering, so I'm going to use this cross section here. So you can see how, like this way, none of the rubber band is wrapped around the tube. So all of the rubber band can be stretched, and that's what you want. You might be wondering about this tube, and what that does is when the rubber band is relaxed, it provides a way for the car to catch the rubber band so that it doesn't drag on the ground. So I've got this powertrain half done. Want to make sure I still have plenty of string here, and I do. So the same way I made this loop here, this string is going to have 2 loops. 1 loop around the rubber band and 1 loop to catch the hook on the back of this car, on the that's attached to the axle next to the handle. So the loop around the rubber band, I'll do it the same way I did the other loop. It's a very simple knot. Do not know off the top of my head what that knot is called. In this case, the loop can be really small. It just has to be larger than the diameter of the rubber band. I couldn't make it that small or any smaller than that if I tried. Could also do a square knot there instead of doing a loop. But here, have that other loop. One benefit to having these loops is that, let's say you tied a knot and it was slightly off center, then you wouldn't get an even stretch out of the rubber band. These loops can slide, they'll naturally slide to the positions where there's an equal amount of tension on both sides of the rubber band. So this gives you a more consistent stretch and makes your data more consistent, which is more reliable. All right, so now I'll reattach this. So to attach this powertrain, all I need to do is slide one end of the string attached to the rubber band through the loop, and then pull until everything is through, and you can see that the only thing attached to that structural part of the car, that cross beam, is that loop of string. Now the other end of the string is also going to have a loop, but I want to make sure that the loop is just long enough to reach this hook in the back, and short enough so that when the rubber band is relaxed, it comes off of the rear wheel. So the way I'm going to do that is I'm going to make sure it's running over the pulley, and I'm not really stretching the rubber band. I have it at that equilibrium point, so I'm keeping the lowest amount of tension that I can on the rubber band, and then I'm wrapping it around the hook. So I'm not really pulling, and once I have that there, I'm just going to hold that the strings together with my hand like this, and I'm going to put a little bit of hot glue right over the string to keep that in place. And then as soon as this hot glue cools down, I'll have my loop. So I just need to wait just a minute for the hot glue to cool. So the idea here is that the loop is in just the right place so that when the rubber band relaxes, it lets go of the rear wheels. I'll just trim this off. So you can see how there's not very much tension here. But just the weight of the string is enough to make sure that it lets go of the rear wheels. So I get all of the energy out of the band, and the car can coast. So the way we get this power, put power into the car, is you just pass the string over the pulley, hook that loop to the rear wheels, and then wind the string around the handle. So you can see how the rubber band is stretched, and that energy will push the car forward, working against friction. And it can also just spin the wheels. Now, something that's very noteworthy is you notice that my car isn't moving, but the wheels are. So all of the energy of the rubber band went into the spinning wheels, and that means that the wheels spinning actually has some energy, more energy than if the car was moving without the wheels spinning. And that means that if you really want to accurately calculate the amount of energy in the speed of the car, you have to figure out how much energy is in the rotation. If you look, there's some notes on these wheels where you can use a weight to figure out what the moment of inertia is for the wheels. And once you find that, you can use the length of the wheels So in this case, the moment of inertia for these wheels is 31 milligrams per meter squared. And if I divide that by the radius squared, you notice that gets rid of the length, the meters. And that's because the meters have to do with how far or how fast the weight or where the weight is on the wheel is moving, and also how fast the car is going to be going at that rate. The simple effect of this is that if I divide by the radius of the wheel, I can get rid of the meters and I'm left with just an amount of mass. So in this case, this set of wheels, both of these together, was 0.016 grams, or 0.016 kilograms, or 16 grams. So if I want to calculate the energy of this car more effectively, what I can do is take the mass of the car and then I add to it the effective mass of this rotating wheel. This relies on the wheel turning in a direct relationship to the speed of the car. And as long as that's happening, we can kind of treat this rotating wheel as if it's just for the purpose of kinetic energy, part of the mass of the car. It isn't actually part of the mass of the car, but the rotation of the wheel effectively can act like an extra mass in terms of the amount of energy the car has for a given speed. In any case, that's a way where if you want to find the energy more accurately for your car, you can do that. But in any case, you should at least get enough from this video to attach your powertrain with the rubber band to your vehicle. So you have one loop here attached to the rubber band, another loop here. The two loops allow the rubber band to be evenly stretched on both sides. And then another loop here that's just the right length to reach the hook on the rear axle and let go just under the weight of the string. And a way of getting that loop set to just the right length is to use some hot glue to hold it together. You could tie a knot, but if you make a knot, the knot itself will shorten the string a little bit. There are some types of knots that you can do that will get around that, but this is, I think, one of the simpler ways as long as you have the hot glue available. So again, this is how to attach the rubber band powertrain for your Formative 4. Thank you and enjoy.